7.4, ratio in the form 1 to n. So right at the start of ratio, we said that we don't like them in fraction form or decimals. We like them in whole numbers. But there are times when we do want to write it in the form of 1 to something, where n can be any number, decimal, fraction, or whole number. Scales on a map tend to be written in this way. And what it means is that there's 1 on the left-hand side of the ratio. To get 1 on the left-hand side, you need to divide through by whatever is on the left-hand side. So if it was in the form of 8 to whatever, you would divide both sides by 8. If it was 10 to whatever, you divide both sides by 10. If you were asked to write it in the form of m to 1, you'd do the same process, but it would have to be the 1 on the other side. So if we had something to 7, we'd divide both sides by 7, or something to the power of 11, or something to 11, we'd divide by 11, and that would mean that the right-hand side would be 1. So example 1, write 4 to 16 in the form of 1 to n. So if we've got 4 to 16, to get it to 1, what we need to do is divide by 4. We need to divide 16 by 4, and we get 4. So the answer there would be 1 to 4. 2 to 5 in the form of 1 to n. So 2 to 5. We need to get it in the form of 1 to something. Well, to get from 2 to 1, we've divided by 2. So divide 5 by 2, and we get 1 to 2.5. Example 3 and 4. So example 3, this time we want to write 12 to 6 in the form of m to 1. So we want to get to the stage that it's to 1. So to get from 6 to 1, we divide by 6. So we need to divide 12 by 6. And we get 12 divided by 6 is 2. So it's 2 to 1. 8 to 24 in the form m to 1. So what we need to do to get from 24 to 1 is divide by 24. So 24 divided by 24 is 1. So we need to divide 8 by 24. And the nicest way to do that is to write it as 8 over 24. Now 8 over 24 is a fraction, and it can be simplified by dividing top and bottom by 8 to leave a third. So what we get is a third to 1. And it's not as a whole number to a whole number, but that's fine. And the easiest way to do these is to put it as a fraction, and then simplify it if you can. So it's not always going to be a fraction that you can simplify, and it might be a decimal, but that's all good. We don't mind that at all. 7.5, map ratio. So map scales can be written in ratios and tell you how many units of land, sea, etc. are equal to 1 unit on the map. If, for example, you're trying to travel from Belfast to Newcastle and you need to know how far it is, it'd be very difficult to work this out if the map didn't have a scale. Finding a map ratio is the same as writing a ratio in the form of 1 to n, where n can be any number, but there must be a 1 on the left-hand side. So that's just common convention then with maps, is 1 to whatever. And the units, it never has any units, and that's because it's the same on the map as it is in real life. So if you were to put your hand down on the map, and the map ratio is 1 to 1,000, the distance that was 1 hand size on the map would be 1,000 hand sizes in the real world. 1 centimetre would be 1,000 centimetres, and so on. So example 5, find the map ratio if the distance of 12 kilometres is represented by 1.2 centimetres on the map. So the map always goes first, so it's map to world, and we've got 1.2 centimetres is 12 kilometres. Now what we want in these is the same units. So right back at the start of ratio we said that we'd like them all in the same units before we simplify them. So we need to change the kilometres into centimetres, and we'll do that in steps. So 1.2 centimetres We'll change into meters first of all. So to change from kilometers into meters, we multiply by 1,000. So that's going to be 12,000 meters. So then 1.2 centimeters is going to be 12,000 multiplied by 100, because there's 100 centimeters in a meter. So we'll put 2 more zeros in. So that's 1.2 million centimeters. So now we can drop the units. So it's 1.2 to 1,200,000. And we don't like decimals, so if we multiply both sides by 10, that'll remove the decimals. And we'll have 12 to 12 million. But we need it in the form of 1 to something, so we need to divide by 12. And 12 million divided by 12 is 1 million. So the map ratio there would be 1 to a million. So 1 centimetre is 1 million centimetres in the real world. 1 footprint would be 1 million footprints in the real world. Example 6, the scale of a map is 1 to 50,000. A distance measured is 3 centimetres on the map. So the map ratio is always map to world. And we've got 1 to 50,000. But what we had was 3 centimetres. So if we went to 3, to get from 1 to 3, we multiply by 3. So 50,000 multiplied by 3 would be 150,000. So that means that 3 centimetres is 150,000 centimetres in real world. So that's how many centimetres it is. We need to find how many metres that is. So to get from centimetres to metres, we divide by 100. So that's going to be 1500 metres. So we've just divided by 100. We've taken off 2 zeros. And then we divide by 1,000. And we get that it's going to be 1.5 kilometres. So 3 centimetres is 1.5 kilometres. Example 7, if a map ratio is 1 to 5,000, find the distance between 2 points that are 12 centimetres apart on a map. So, we'll start off the way we have been. So we've got map to world, and it's 1 to 5,000. So that means that 12 centimetres is going to be 60,000 centimetres in the real world. So to do that, to get from 1 to 12, I've multiplied by 12, 5 by 12, or 5,000 by 12. So if we think about 5 times 12, that gives you your 60, and then we've 1, 2, 3 zeros following that. So it's 60,000. 60,000 centimetres though is the real distance, but it doesn't really make sense to me anyway. So if we divide it by 100, that would change it into metres. So that's 600 metres, which is a bit more reasonable. You could, if you wanted, change it into kilometres, and it would be 0.6 kilometres. And either 600 metres or 0.6 kilometres is a lot more reasonable, and you can picture that better than you could 60,000 centimetres. Part B, if the actual distance between the 2 points is 3 kilometres, find out how far apart they are on the map. So if we think about the scale, which was map to world, I'm going to build up to 3 kilometres. So 1 is 5,000. So what that means is 1 centimetre is 5,000 centimetres. Again, that doesn't really make an awful lot of sense to me. So I'm going to write it as 1 centimetre is 50 metres. From there, I can get that 10 centimetres would be 500 metres. And I could get that 20 centimetres is 1,000 metres, or 1 kilometre. And then from there, to get from 1 kilometre to 3 kilometres, I'll multiply by 3 to get 60 centimetres. So the actual distance between the 2 points on the map would be 60 centimetres. Now, sometimes they may not build up in the same way that I was able to build them up. So if you were able to get to the stage of 1 centimetre to 50 metres, what we could have done at that stage, alternatively, was to divide our 3 kilometres by 50 metres. And to do that, we would do 3,000 divided by 50, which would give us 60. And then to get from our 50 metres up to 3 kilometres, we'd multiply by 60. So then we'd have to multiply by 60 on the left. So dividing your distance that you're trying to find, so in this case it was our 3,000 metres, by how far 1 centimetre is in the equivalent units, will tell you how many times you multiply up by, and then if you multiply the 1 centimetre by whatever that value was, you would get up to 60. And now you should be able to do exercise 5E on page 99 if you're working with the old books, or 5D on page 100 with the new books.